Hello students, how are you all? I am your chemistry faculty, Mohan. Welcome to once again Akshar online classes, right? So students, today we will continue with our chemistry and that is second synopsis, ancient views about atom. So students, actually now we are entering into the chapter called atomic structure. Very important concept. And this is very important because this will continue for your further class also, even in the 9th class, 10th class, and if you go to the intermediate level, 11th standard also. In the 11th standard, the first chapter is atomic structure, right? So it's a very important chapter. So just concentrate on my explanation. Is this clear now? Let's start atomic structure. So this is actually our atomic structure. Okay. Now let us see what is atomic structure. So as already you know that any matter is composed by an small particles called atoms, right? So this view, this concept was known to the ancient, Indians, even Greek philosophers also, right? Even if you see in our Indian philosophy also, we had this concept that any matter is made up of a tiny particles called atoms. So here we can call it as a paramanu in English, sorry, in Telugu, okay? So any matter, any padartham, whatever it may be, so we can call it in Telugu padartham, that is made up of a tiny particles called paramanu. Okay, so this concept was in India, it was there, and the same concept was known in Greeks also. Okay, so the Greek also, the ancient Greeks, they knew that concept that any matter is made up of tiny particles called atoms. Like already I told you that if you take one matter and if you break, so it can be broken into two pieces like this continuously break. Finally, a stage will come where we cannot break that atom, okay, that's a small particle, that particle is called as an atom. So according to this concept, atoms are indivisible. What are that? Atoms are indivisible. Means what? We cannot break that smaller particles called atoms, and atoms only the smallest particle. This was the concept. Okay. So based on this, Dalton's atomic theory was proposed. That also we already discussed in the previous classes. Okay, Dalton's atomic theory. Right. Now today we are going to discuss about the J.J. Thompson's. J.J. Thompson, how he disproved atomic theory, means how he proved that atomic theory was wrong. What is atomic theory according to Dalton's atomic theory? Atoms are indivisible. So that was disproved, means that was proved as wrong by J.J. Thompson by his famous experiment called a discharge tube experiment, right? So students, now listen now here. Discharge tube is nothing but a small glass tube. So like this is a glass tube, and okay, this is a glass tube of about nearly 60 centimeters. Okay, 60 centimeters, and here in this glass tube, the two electrodes were fitted. Electrodes means what? A metal plates, nothing but a metal plates. So here this is one electroplate, and let's take here, this is one electroplate. So one metal plates we take, these are called as electrodes, okay? And these electrodes are connected to the high voltage battery. Okay, like this, and here what we do, yeah, okay. So here red is positive, we are taken, this is, see, you know, this is a bigger line, positive, and this is a negative. So this is positive terminal, this is a negative terminal, right? So here and here one small, okay, tube was arranged here. This is a small tube which is called as a discharge tube. What it's called? A discharge tube. So this was an experiment. So very simple experiments here. This is a discharge tube, a small glass tube about 60 centimeters in length, and here inside two metal plates are fixed, so which are called as electrodes, and one metal plate is connected to the positive terminal, which is called as an anode. What it is called? An anode. And the second plate is connected to the negative charge, that is called as a cathode. What is called a cathode? Right. Now, here the voltage is applied greater than 10,000 volts. 10,000 volts is applied. Okay. So, when the more than 10,000 volts electric current is applied, and the pressure inside is decreased. Pressure inside is decreased to 0.01 mm. 0.01 mm of pressure. Then it was observed that a rays, okay, so which is called as a cathode rays. So some rays are emitted from this cathode, okay, and they move towards, okay, like no problem. So there, this is a cathode. So from these rays are emitted from the cathode, and they move towards the anode. Where they are moving? Towards the anode, right? So this rays, which are, it is a cathode, so the rays are emitted from the cathode, released from the cathode, and these rays are moved towards the anode. So here these rays are named as a cathode rays. What they are named as? Cathode rays. Okay, why they are named as cathode rays? Because they are emitting from the cathode, and they are moving towards where? They are moving towards the anode. So here they are named as a cathode rays. From where these cathode rays are released? Okay, so here later, actually first they thought that these are the rays, okay, they are named as a cathode rays, okay, cathode rays, and later it was observed that these were not a rays, but these are the negatively charged particles. What are they? Negatively charged particles, which has a negative charge. Okay, these are the particles. These are not rays, these are the particles. Okay, so these particles are later named as electrons. What they are named as? Electrons. Electrons. Okay, so you might have already learnt about the electrons, protons, neutrons, right? So here these are the electrons. From where they are emitted? So here, under these conditions, the gas molecules which are present inside the glass tube, they got ionized. What they got? Ionized. Ionization is what? Like splitting the neutral molecules into ions. Means from that the electrons are released, and these electrons, okay, was discovered by the J.J. Thompson. Who discovered it? J.J. Thompson. Very important. So J.J. Thompson was a scientist who got the credit of discovering the electrons, and he was the person, by discovering the electron, proved that Dalton's atomic theory was wrong. Means what? The previous concepts, like ancient concepts, were wrong, right? So because previous concepts, what did they told? The atom is the smallest particle that is indivisible, right? But here, okay, J. Thompson proved that atoms can be divisible, and when the atom is broken, from that, okay, a more tiniest particles, okay, electrons are released. Is this clear to you? So this was the J.J. Thompson's experiment. Clear, students? Any doubt in the J.J. Thompson's experiment? Very simple experiment. Okay. Now, J. Thompson, you can see this J. Thompson experimental tube in the page number 16. Okay, in your material, you can see in the page number 16. Clear now? Now, J. Thompson not discovered this cathode rays, and he also means electrons, and he also gave some, okay, properties of the cathode rays. Okay, so what are these important properties? So now let us see, students, now properties of cathode rays. Properties of cathode rays. Right? So very simple properties are there. Very simple properties are there. The first property is these electrons, means cathode rays, okay, travel in a straight line. Okay, the cathode rays are traveling in a straight line. From where to where? From cathode to anode. From where to where they are moving? Cathode to anode, moving in a straight line. Is this clear? That's the first thing. And second thing is that these are observed that these are not a rays, but these are the negatively charged particle. Okay, negatively charged particle. Okay, first let us see they are considered not a rays, but these are the particles. How this J. Thompson came to know that they are the particles? So if you see here in this experiment, so first they thought that these are the rays, they are moving from cathode to anode, right? So rays cannot produce the mechanical energy. Remember that. Rays cannot produce the mechanical energy. Okay, but here what happened? He placed one wheel here. Okay, he placed one wheel here. Okay, so like this he placed one wheel here. So then what happened? When these rays are striking to this wheel, and this wheel started the rotation. Okay, the wheel started rotating. So the meaning is what? They are producing some mechanical energy. So due to which that wheel, a light wheel, was rotating. So from this experiment, he came to know that. Okay, these are not a rays, but these are the particles. Clear? Now third one, what I said, they have the negative charge. Okay, then we do that. These are the first. Okay, so these are the particles. These are not rays, but these are the particles with some mass. And third one, what is said that they have the negative charge. Now, how we came to know that they have the negative charge? So students, here what I said is that these are moving in a straight line. That's the first thing. Now here what he did is he placed some charges. Okay, some charges on the either side of this plate. Means what? He arranged some positive charged plate here. Okay, this is a positively charged plate and this is a negatively charged plate. Okay, so he kept two plates here. One is positive, one is negative on either side of this glass tube. So then what happens? These rays actually initially they were moving straight line, and the moving they are straight. But now here what he observed is when he placed like this positive and negative plates, okay, on either side, it was observed that instead of moving in a straight, these rays, okay, instead of moving these rays now straight, then what happens? These rays are deflected toward the positive charge. Okay, instead of moving straight, they are deflected towards the positive charge. Right, like this, they are deflected towards the positive charge. In the previous, what I said, they will be moving in a straight line when in absence of electric field. In absence of electric field means there is no electric field here. Okay, so just here one negative terminal, this is a cathode, one positive terminal, that is anode. That's all. Okay, but now what he has done, he arranged the electric field on both the sides of this glass tube. Okay, so both the sides of glass tube, he arranged one electric field, that means positive charge one side and negative charge another side. Then what happens? He observed that these rays are attracting towards the positive charge. They are deflected towards the positive charge. Is this clear? Now the question rises that now how he came to know? Of course, he is deflecting towards the positive charge, but now how he came to know that they are the negatively charged particles? Come on, tell now. Guess. So here these rays are deflecting towards the positive charge. Okay. Now this particle, how can we come to know that these are the particles with negative charge? Come on, students, guess fast. Very good. So here they are deflected toward the positive charge means they are negatively charged. Why? Because already you might have learnt in the lower classes that unlike charges attracts, like charges repel. Is this clear? Unlike charges attracts, like charges repel. Okay, so here they are attracting toward the positive means what? Which charge are attract? Unlike charges. So if it is positive, then unlike means what? Opposite charge. Opposite charge is what? Negative. So there is a force of attraction between the unlike opposite charges, and there is a force of repulsion between the like charges. Clear? So in this way, he came to know that these are the negatively charged particles. Is this clear to you? They are the negatively charged particles. Okay, and okay, so these are the some of the properties of this one. So they are moving in a straight line. They are okay. They are the particles and they are the negative charge. And even you see here, they form the scintillations also. Now it's not required, but okay, they form scintillation. Scintillation means what? Like sparks. Okay, when there is one, there will be one screen which is called as a fluorescent screen. Fluorescent screen means you can say that the screen which is coated with even zinc sulfide also. Okay, for example, one screen like this is a screen and it is coated with zinc sulfide. It's coated with what? Zinc sulfide. And now when it's coated with the zinc sulfide, when any charged particle like electrons are coming and strike to this one, then what happens? Where it strikes, it gives a flash like light. Okay, it like gives like spark. That's called as a scintillations. What it's called? Scintillations. So here electrons can produce a scintillation. Scintillation is what? Sparks. Okay, this I'll explain you again in the Rutherford experiment once again. So remember this point that when negatively charged particle strikes the fluorescent screen, that causes the scintillations. Okay, so these are some of the properties of cathode rays. Clear? Any doubt? Yeah. Now the question arises that, sir, if you have a negative charge to them, then what is the value, magnitude of that charge? What is the magnitude of that charge? So here J.J. Thompson could able to explain that negative charges present on it, but he could not able to explain what amount of charge is present on it. But he calculated the ratio of charge to mass of an electron. What he calculated? He calculated charge to mass, which is called E by M ratio. What it's called? E by M ratio. So J.J. Thompson was the person who calculated E by M ratio of electron. Clear to you? Okay. Now, alright. So E by M ratio of the electron. So that is what the ratio of charge to mass. E represents what here? Charge. Okay. And M represents what? Mass. Charge to mass ratio of an electron was calculated by the J.J. Thompson. Right. Now, after the discovery after this one, okay, E by M ratio, then another scientist called Millikan. Who is the person? Millikan. Millikan conducted one oil drop experiment. Which experiment? Oil drop experiment. So oil, just remember, okay, try to understand Millikan oil drop experiment. Now actually we are not dealing with that Millikan experiment because here it is not important to that experiment total, but just you have to remember. So here Millikan oil drop experiment is what? What he has done is he has taken one okay, vacuum chamber. This is what? Vacuum chamber. And he arranged one small slit here. What is that? Slit means what? A small gap. Okay, small gap is there. And here he placed one atomizer. What it is called? Atomizer. Atomizer. Atomizer means what? Here when the oil is passed through this one, it like sprinkle the oil. Okay, so very tiny drops of sprinkle, and he arranged the positive and the negative plates in this okay, vacuum chamber. He arranged one positive and negative plates in the this vacuum chamber, and then he dropped that with the help of atomizer. He dropped the oil drops in this one vacuum chamber. Then he calculated the velocity, the terminal velocity. Also, you can say that velocity of an electron with which electron is falling towards the positive electrode. So based on this, he calculated the charge of an electron. What he calculated? Charge of an electron, and the charge of electron is 1.602 into 10 to the power of minus 19 coulombs of negative charge. This you have to remember. Millikan drop oil experiment is not required to us. Okay, experiment you need not to remember. but this you have to remember what is the charge on electron. So, electron carries a negative charge. Electron carries a negative charge, but how much charge? How much charge is present on the electron? So, the charge that is present on the electron is 1.602 into 10 to the power of minus 19 coulombs. Very important. So, this value you need to remember. Okay. So, this is the charge on the electron, right? And based on these values, and they also calculated the mass of an electron. They calculated what? Mass of an electron, and mass of electron is found to be 9.21. Okay, 9.1 into 10 to the power of minus 31 kgs. Okay, so this is a mass of electron. This is what a mass of electron. See students, these are both values are very important. In the chemistry, we need to remember these values because we are going to solve so many numericals. So there where we required to remember these values. Okay, so 9.1 into 10 to the power of minus 31 kgs. Is this clear? Do you know what is the minus 31? Can you guess what is the meaning by minus 31, 10 to the power of minus 31? See, already I think you might have studied in the mathematics, like a to the power of minus m. What is the meaning of a to the power of minus 1? A to the power of minus 1. Good. So, that is 1 by a to the power of m. Right. So, here 10 to the power of minus 31 means what we write? 1 by 10 to the power of 31. 10 to the power of 31 means what? 1 beside 31 zeros. It's a very, very big number. Okay. So, that is a mass of electron. Means what? Here, the mass of electron is negligible. Negligible means what? Almost nothing. Almost nothing. Even when you calculate the molecular masses also, mostly we neglect the mass of electron. Okay. So, that is a very, very small and very, very less mass which is almost negligible, right. So, now you remember these two values. One is 6.02 into 10 to the power of minus 19 coulombs. This is the charge of an electron, and here C coulomb. Here this is called C means what? Coulomb. Coulomb is the unit of charge. To measure the charge, we use the unit coulomb. And this you know this 9.1 into 10 to the power of 31 kg. So, you know that kg is the unit of mass. Clear? Any doubt till here? No? Okay. Then let us go to the next topic. Okay. Now then come to the discovery of protons. Student, discovery of protons. Protons also one of the particles which are present in the atom. Okay. So, how the electrons are present. Similarly, protons also particles which are present in the atom. So, students here, see, try to understand here. When J. Thompson discovered the electron, then he had a lot of questions in his mind. Okay, like generally, atom is neutral. Atom is what? Neutral. Neutral means what? Neither positive nor negative. So, if we take one atom, atom is neutral. So, it is not negative nor positive. Means no negative charge, no positive charge, it is neutral. But J. Thompson discovered the electrons from it. Discovered what? Electrons from it. Right. So, electrons are what? Negatively charged particles. What are the electrons? Negatively charged particles. Okay. So, here if only electrons are present in the atom, imagine if only electrons are present in the atom, then atom should possess a negative charge. Yes or no? Because if only electrons are present, electrons are negatively charged. If only electrons are present in the atom, imagine that if only electrons present in the atom, then atom should possess a negative charge because electrons are negatively charged particles. But atom is neutral. But atom is neutral. So, what is the meaning of that? What is the meaning of that? See, atom is neutral. Neutral means what? 0. In mathematical terms, I am writing like atom is 0. It do not have any charge. Right. Now I found that there are some electrons are there. Electrons means what? Negatively charged particles. Let you see here some new electrons are there. For example, I am say that there are some 2 electrons are there. 2 electrons and electrons carries a negative charge. Electron carries what? A negative charge. So minus 2. Clear? Now here negative charge is there, but atom is neutral. So to make this minus 2 into 0, to make this minus 2 as 0, now what I should do? Come on, tell. I should add plus 2. Okay, when I add plus 2 to minus 2, then this becomes 0. Yes or no? Right. So if only, for example, this is not there, this plus 2 is not there, only imagine that only minus 2, only electrons are there. Then this atom also should possess negative charge only. This atom should possess negative charge only. Yes or no? But atom is neutral. Atom is neutral means what? Here how many negatively charged particles are there? Equivalent of positive charged particles also should be there. Clear, no? Are you following? For example, if it is there minus 5 is there. To make it 0, then what I should do here? I should add plus 5. So this becomes a 0. Yes or no? So how much negative charge I have? Okay, if I want to make it to 0, then I require same amount of positive charge also. Are you following? Okay, so atom is neutral. Atom is neutral, neither positive nor negative. Okay, but J. Thompson discovered the electrons from it. J. Thompson discovered what? Electrons from it. Electrons are what? Negatively charged particles. If only electrons are present in the atom, then atom should possess a negative charge. But atoms are neutral. The meaning is what? How much negative charge is present? Equivalent to that, is equal to that, there should be some positive charge also. Yes or no? So those positive charge, how this positive charge is present, that J. Thompson did know. So later some other experiments were done, and here Goldstein was the person who discovered the protons. Who discovered what? Protons. And protons are also a subatomic particles, okay, but which have the positive charge, which have what? A positive charge. So these protons making the atom neutral, Is this clear to you? So this is about the protons. So protons are the positively charged particles, students. So protons are positively charged particles. Positively charged particles means they have the positive charge, 1 unit of positive charge, and it was so the amount of whatever the negative charge is present in the electron, the amount of charge that present on the proton is also same, only opposite. Means what? If the electron has a negative charge, the proton has a positive charge. If anyone asks you what is the charge on the proton, so charge on the proton is nothing but a 1.602 into 10 to the power of minus 19 coulombs. So this number you see, this number is 1.602 into 10 to the power of minus 19 coulombs. Okay, so here what I gave the charge of electron 1.602 into 10 to the power of minus 19 coulombs. Yes, so the charge is same. Then what is the difference? Here electron carries this amount of negative charge, 1.602 into 10 to the power of minus 19 coulombs of negative charge, whereas 1.602 into 10 to the power of minus 19 coulombs of positive charge. Is this clear? So this is about the protons. So protons are the positively charged particles, and here the mass of the proton compared to the electron is more, and it carries 1.602 into 10 to the power of minus 19 coulombs. Okay, so these are the second particle which was discovered from the atom. First one is what? Electron. Second is what? Proton. Okay, and later there was one more particle was also discovered, that is called as a neutron. What it's called? A neutron. Okay, later another particle was discovered, and that particle discovered by the Chadwick. Who discovered it? Chadwick. Okay, so Chadwick later, after so many years, that is in 1932, okay, Chadwick discovered the neutrons. Okay, so neutrons, the name itself it is said neutral. So neutral. Neutral means what? They do not have any charge. The amount of charge is present on them is 0, but they have the mass approximately equal to the proton. Mass approximately equal to the proton. So in this way, James Chadwick discovered the neutrons in 1932. So later some other particles also discovered from an atom, but these three particles are considered as very important particles which can affect the properties of atom. Hence, these three particles are called fundamental particles of atom. What they are called? Fundamental particles of atom. Is this clear? Or we can say subatomic particles. What are they? Subatomic particles. What are these? Electrons, protons, neutrons. Right? So electrons, protons, and neutrons, okay, are fundamental particles, or we can call them subatomic particles. Okay. So students, here you see here you see, just I am drawing one small table. Here we write the particle. Okay. Here we write the charge, and you write the mass. Alright. So here the charge, first one we write the electron. Okay. Second one we write the proton, and third one is the neutron. Okay. So here, what is the charge? I said 1.60 into 10 to the power of minus 11 coulombs. Already said no. So that is the charge, but we can write simply we can write 1 unit of negative charge. Okay, 1 unit of negative charge, which is equal to 1.60 into 10 to the power of minus 19 coulombs. Right. Now here similarly, proton 1 unit of positive charge. 1 unit means what? 1.60 into 10 to the power of minus 19 coulombs. And this is neutral. Neutral means what? 0. Okay. Next, the proton mass is taken as approximately 1 AMU, or we can take 1.0078 AMU. AMU means what? Atomic mass unit. Nowadays, it is also represented with the capital U, which is called as a unified mass. What is called? A unified mass. And the neutron mass is also equal, but approximately just very slight, 1.0078 and 1.0087 AMU. So this is also called a unified mass. So just we take 1 AMU, 1 atomic mass unit, and whereas the electron charge is approximately 1840 times of a proton. Okay, the mass of electron is 1 by 1840th part approximately of the proton. The meaning is what? 1814 electrons, if they put together, then that makes the mass of the proton. So the meaning is what? The electron mass is very, very less. It is negligible. It is what? Negligible. Clear to you? So today, students, so this is about the fundamental particles of atom. So this synopsis, with the synopsis 2, perfectly once you read, and in the next class we are going to solve this exercise, and here some important values I told you, that if you want to see, once you can see the page number 21. In the page number 21 you have one table is there. Once if you see the particles, okay, properties of fundamental particles, there are some properties are there. Those properties you need to learn, right? So this once again we discuss these particles properties in the next class, but you want to go through this one, and then we are going to solve this exercise in the next class. Clear? Any doubt? If you have any doubt, you can post in the chat box, so that I will come to know what to be explained once again. If you have any doubt, I can clear those doubts. Okay. So today's your work is to read the synopsis 2 perfectly, completely, right? And after that, there were some properties are there. Of course, I discussed the properties here, but once again, let's go through those properties, right? And in the next class, we solve the practice sheet 2. Clear? Okay then, take care. Bye.